laser sky is an effect where you make a plane of laser light and shine that into some smoke or fog, and it'll illuminate the medium so you can see how the air flows and swishes around. It's really fun to look at. One way to make laser sky is to use a many-sided mirror like this that spins and shine a laser on it. The reflection of the laser will sweep out a plane. So in this video, we're going to go from a janky setup like this one to a more robust boxed up project like this that has some safety features built in. We're also going to make an optical switch from scratch. So let's get started. The first thing to do is make the spinning mirror wheel. I measured the mirrors with a caliper. For the motor, I'm using a PC fan. I need this to fit just right in the mirror wheel, so I printed some tubes to check the fit. The tubes have a variety of inner diameters, and in the right light you can faintly see steps where the diameter goes down by 0.2 millimeters. With everything measured, I modeled the mirror wheel on the computer, printed it on the 3D printer, dropped in the motor, and glued it into place. I want to attach the mirrors temporarily so I can check their alignment, so I'll be using double-sided tape. I cut lots of small pieces of double-sided tape, stuck them to the mirror wheel, and then pressed the mirrors into place. Now I can put the laser pointer and mirror wheel on a stand and start to check the alignment of the mirrors. I spun the dots in front of a piece of paper and marked their position, and found a couple mirrors that were a little bit out of alignment. The mirrors were removed and then adjusted with a few more pieces of tape. Once I got it looking pretty good, I used epoxy to lock everything in place, and now that it's sturdy, I can spin it up to full speed. It's quiet. Oh my gosh, okay. Alright, now that the mirror is done and ready to go, we can start playing with the laser. The power limit for lasers you can buy in the store is 5 milliwatts. This one is 200 milliwatts, and that 5 milliwatts number is supposed to be something that won't damage your eyes. When you buy a laser from an untrusted source, even if it looks like it's not bright, it's possible that the laser is emitting infrared light, which can still damage your eyes, but you won't notice that it's there. So just be extra careful. Use safety glasses and be careful about where it's pointing. Alright, now that we have the basic functionality working, I want to make it a little bit more robust and a little bit smarter. So we'll use an Arduino to give it some brains, and the Arduino is going to control the power to the laser and to the mirror wheel. The laser bouncing off the mirror wheel is what gives us our laser sky. I also want to sense the speed of the mirror wheel so that I can know whether it's spinning or not and make sure that it's spinning at the right speed. So for that, we'll use an optical switch. With the optical switch, we can sense the motor speed and have a closed loop control of the motor. Let's go make this right now. The optical switch starts with an optical resistor. I set my multimeter to measure resistance, connect it to the leads of the resistor, and find that its resistance varies between 30 kiloohms in the light and 1 kiloohm in the darkness. Unfortunately, the Arduino can't measure resistance, so we have to use the optical resistor to create a voltage signal that the Arduino can sense. One way to do this is with a voltage divider circuit. A voltage divider circuit involves current flowing across two resistors in series, let's say from 5 volts to 0 volts. The top resistor will have some resistance, R1, and some voltage drop across it, V1. The bottom resistor will be our optical resistor, with resistance ROR and voltage drop VOR. Intuitively, V1 plus VOR is 5 volts. But what is VOR? Well, we know that voltage is proportional to resistance, and we also know that both resistors have the same amount of current flowing through them. If you work with that, you'll find that VOR is equal to the fraction of ROR over the total resistance multiplied by the total voltage. So as ROR changes, VOR also changes. We can connect a wire here to measure that change. I took the resistor and optical resistor, connected them to the breadboard, and added a wire to measure the voltage across the optical resistor. We can switch the multimeter from resistance mode to voltage mode. I connect a power supply to the circuit, set it to 5 volts, and turn it on. Now we can see a voltage that varies between 4 volts in the light and 1 volt in the shade, a change that can easily be measured by an Arduino. I add an LED to the circuit so that we can have a consistent light source, and find that the signal is a bit weaker now, but still measurable. At this point, we can get rid of the multimeter and power supply and connect everything to the Arduino. I connect analog pin 5 of the Arduino to the positive lead of the optical resistor, and power the circuit using the 5-volt and ground pins on the Arduino. My goal now is to blink an LED using the optical switch, so I plug the Arduino into my laptop and start writing a program. First, we need a handful of variables. Sense pin tells the Arduino which pin the optical switch is connected to, and sense val will store the reading. LED pin and LED val will be similar except for the LED. Trigger threshold is the level at which we consider the switch to be triggered. First, we have to tell the Arduino that the LED pin is an output. Void loop is the part of the code that loops over and over, so we'll store the value of the optical switch to the sense val variable, and then do some conditional statements. If the sense value is above the threshold, we'll turn the LED on using digital write high. Otherwise, we'll turn the LED off using digital write low, and that will be our whole program. I upload the sketch to the Arduino and check it again with my Chipotle card, and sure enough, it works. Happy time. Okay, I'm finally done programming the machine. To turn it on, you just plug it in. When you first start it on, the LED breathes to show that it's ready to go. And to start the machine, you flip the switch, and it will start spinning up the mirror. It'll wait for 5 seconds of good mirror spinning before turning on the laser. Flip the switch back to turn everything off. The situation I want to avoid with this machine is to have the mirror stop while the laser's on, and which would send a death beam outside of the box. So when the laser's on, it's also looking at the mirror speed, and if it senses the mirror going too slow, it cuts power to everything and enters safe mode with the blinking light. To start it up again, you reset and go. Now that it all looks good, let's make a box for it. All right, folks, that's it for today. Thanks for watching. Let me know if you have any thoughts. For example, one thing I could use help with is knowing how much detail to go into with the different topics. I want people to be able to follow along, but I don't want the video to be so long that it turns people off. So let me know what you think. One funny thing that happened is before I put the top on, I literally sat on the mirror and it didn't break. I really want to take it camping and shine it through a campfire. That'll be cool. If you like this video, please subscribe, and until next time, I'll see you later.